We'll look at the solution for JA4 of Tournament of Towns. Okay. Question says as an equilateral triangle ABC. And so we have equilateral and we're constructing a few points outside the triangle over here. So these points are A prime, B prime, C prime. Now we're constructing this hexagon over here. And we are given the equal lengths. We're given AB prime equals AC prime, CB prime equals CA prime, and BA prime equals BC prime. So those are the given lengths. We're also given angle B prime AC prime, angle C prime BA prime, and angle A prime CB prime are greater than 120 degrees. And the question is to prove we make these lengths x, y, and z. Prove this lengths x, y, and z form a triangle. Okay, so what we notice is to prove the lengths x, y, and z form a triangle, it's equivalent to show the triangle inequalities. So prove that x plus y is greater than z, y plus z is greater than x, and x plus z is greater than y. So it's equivalent to show that these three inequalities are true. And now we'll start by solving a slightly simpler question, which will help us to solve this question. The simpler question is an equilateral triangle ABC. This equilateral triangle ABC, and now there's a point D, any point D inside the triangle. And the question is to prove that DA, DB, and DC form a triangle, or form the lengths DA, DB, and DC form a triangle. And to prove this, we can move around these three lengths and try to construct a triangle. So we have a 60 degrees angle here. And what I'll do is I'll construct the point D prime. So construct D prime such that triangle ADD prime is equilateral. So I'm constructing D prime to make this triangle equilateral. So now if we make CAD equals alpha, then angle DAB will be 60 minus alpha. And since DAD prime is equal to alpha, is equal to 60, it means that this angle here is also alpha. So we have an alpha, a 60 minus alpha, and an alpha. And now, if you look at triangle CAD and triangle BAD prime. Look at these two triangles. We see AC is equal to AB, AD is equal to AD prime, and CAD and BAD prime are equal to alpha. So it means the two triangles are congruent by SAS. And now, if we compare the lengths CD, we will get CD is equal to BD prime. So this length over here, this length over here is equal to this length over here. And now we also have this length over here. But now we see that triangle BDD prime has the required lengths because we have the length BD, BD prime is the same as CD, and BD prime is the same as AD from the equilateral triangle. So this is ends the proof of the lemma, where this triangle over here has the lengths of AB, DA, DB, and DC. So now so what we notice is, since they form a triangle, we obtain the three you can use the triangle inequalities for DA, DB, and DC. And now for the original question, what we can do is try to apply this lemma here. And what I'll do is I'm going to rotate. If you look at this triangle here, I'm going to rotate triangle B prime AC onto side BC. So we see that since CA and CB have the same length, we can do this rotation by moving this point B prime here to a point D. So we constructed D such that triangle BDC is congruent to triangle AB prime C. So now we can use the equal length, so we get X over here, Y over here. And let's say, let's make this, I make this length W, so dA is equal to W. And we can also do some angles, we can also look at some angles. So if we make this angle alpha, then you know from congruent triangles that this angle is equal to alpha. So B prime AC and DBC are the same, and this angle is 60 from the equilateral triangle. Let's say this angle is equal to beta. And we know since B prime AC prime is greater than 120 degrees, we know alpha plus 60 plus beta is more than 120, which means that alpha or beta, so if you can say that 60 minus, say beta is greater than 60 minus alpha. What we see here is this angle is 60 minus alpha. And now what we'll do is, remember that DA, DB, and DC form a triangle from the previous lemma, which means that W plus X is greater than Y, W plus Y is greater than X, and X plus Y is greater than W. But now the inequalities we want are these ones involving X, Y, and Z, but they seem like we're quite close because we have inequalities involving W, X, and Y. So what we could now do is try to compare the values of W and Z. And it turns out this is not too difficult because we can apply the cosine rule. So what we see is, if you look at triangle DAB and triangle DAB and triangle C prime. Yeah. So triangle, let's write it as DBA. Triangle C prime AB. So what we see, if we want to find W, let's say that AB is equal to U. So now, if AB is equal to U, we can write W squared equals U squared plus X squared minus 2 UX cos 60 degrees by the cosine rule on triangle DAB. And from C prime AB, the cosine rule is, so now we want to apply it to Z because we want to compare W and Z. Z squared is U squared plus X squared minus 2 UX cos beta. But now we know, since beta is greater than 60 minus alpha, it means that the inequalities for cosines are in reverse. So cosine beta is less than cosine of 60 minus alpha because cosine decreases as the angle increases. But now what we see is, if we compare W and Z, these are almost the same equations except we have the cos beta and the cos 60 minus alpha. But since cos of beta is less than cos of 6e minus alpha, it means in Z we are subtracting a smaller number. Since we're subtracting a smaller number where cos of beta is less than cos of 6e minus alpha, it means that Z squared has to be greater than W squared. And it means that Z is greater than W. So now, since we know that Z is greater than W, we can apply to these inequalities here. So it means that Z plus X is greater than Y because Z is greater than X. Z plus Y is greater than X. And how we actually got, using this, we've gotten 2 of the inequalities we need. So this is the only one we don't have. Turns out, by symmetry, you can use a similar argument to obtain this inequality as well by, for example, instead of considering this triangle, instead of rotating this triangle, you can rotate maybe this triangle, for example, and similarly get that X plus Y is greater than Z. So that proves the 3 triangle inequalities and proves that the lengths X, Y, and Z form a triangle. So that completes the proof.